Hello everyone, welcome to the class where we are discussing fluid dynamics. In this part, in this class, we shall discuss about Bernoulli's equation. We shall learn how to write the mathematical form of Bernoulli's equation, and later in the next part, we shall derive the Bernoulli's theorem. Right? So Bernoulli's theorem actually relates the speed of a fluid at a point, the fluid pressure at that point, and the height of that point above a chosen reference level. Right, so we shall eventually discuss it, and it is nothing but the application of the work energy theorem that we studied in the work energy and power chapter, so in case of fluid flow. So this is just a work energy theorem in case of the fluid flow. So before starting the Bernoulli's theorem, let us learn about the energy of liquid. Energy of a liquid. This is equally true about the gases. So basically, this is the energy of fluids. So a fluid has three types of energy while in flow, right? And what are those? Number one, that is kinetic energy. Kinetic energy, Ke, that is, and this is due to what? This is due to the motion, right? Motion, this is due to motion, right? And number two, it does have potential energy. Pe, and that is due to what? That is due to the position from a chosen, with respect to some chosen reference level. And number three, which is very important, that is pressure energy. That is pressure energy. And this pressure energy is due to the existence of pressure. Every fluid, this does have some pressure. So due to this pressure, we have this pressure energy. Now one by one, I shall be deriving the formulae or the expression for this three kinds of energy. First one, the first kind is the kinetic energy. So as you have already know, that kinetic energy is basically what? Is basically half mv square. So Ke is equal to half mass into v square, velocity square. So we shall be discussing in great detail while proving the Bernoulli's theorem, while applying this formulae, this kinetic energy and potential energy and pressure energy in case of a fluid flow through a tube, right? And the next part is what? Potential energy. So the potential energy, that is due to the position with respect to a chosen reference level. So if a particular body, particular liquid, solid or gas, if that object or that liquid or fluid of mass m, it at some height h of from the reference level, suppose this is the reference level, and suppose here is some fluid here, suppose this fluid, if this is of mass m, this fluid element, and if this is at some height h from the reference level, then the potential energy Pe is equal to mgh. We all know that, right? And number three is pressure energy. This is some thing new to use, I guess. This pressure energy is due to the pressure. So let us say, suppose here is a container, right? And to that container, I have this kind of opening with this container, which is tube, suppose. And to this container, at this bottom, there is a tube, side tube, and is fitted with some frictionless piston. So let us say here is uh, frictionless piston, some frictional piston. And initially, let us say this pressure on this piston, let us say that is P. And the area of cross section of this piston is, let us say, capital A. So what is the pressure of the piston? pressure on the piston, frictionless piston, right? Piston is equal to capital P, and the area of cross section is A. So if the piston, suppose if the piston moves, suppose initially it was here, now the piston, if it moves here, let us say it moves by this much distance of suppose x, then what is the work done? Work done to move the piston by distance x is what? Force into displacement. And what is force? What is force? That is force into displacement, and displacement is x, and force is what? Force is pressure into area multiplied by x. So that is equal to capital P, capital A, and small x. And this work done is stored as the pressure energy inside this column of liquid lying here. Inside this much column of liquid lying here in this liquid. That means if it is the initial position and this is the final position, that inside this volume, the pressure energy is conserved here inside this blue portion, or inside this let us say this blue portion, inside this portion. This is the initial position and that is the final position of the piston, and that distance is x, and inside this volume this PAX pressure energy, so this work done is stored as pressure energy inside the liquid column rho AX, this volume, right? So we have already discussed about the kinetic energy, potential energy, and pressure energy. So that is all for today, and the next class we shall be discussing about Bernoulli's theorem and we shall learn how to derive it. Thank you.